So we can call this 1.5 part 2. I skipped the domain question, so we're going to focus on domain today. So looking at number 4, we want to find the quotient of two functions, then find our domain for f divided by g. So always when you're dividing, when you have the quotient of your two functions, you need to check the domain, because what can we not have in the denominator of a fraction? It can't be equal to what? What can the denominator not be? 0. So this is what we're checking for. The denominator can't be 0. Also, we need to check the domain. If we have square roots, what can we not have under the square root? Negative. So the under the square root would have to be greater than or equal to 0. Bless you. So these are the two main things that we have to keep an eye out for when we're talking about domain. So in example 4, we want to find the quotient of two functions. So it gives us f and g, and it asks for f divided by g. So I'm going to start by putting f on top. So f over g of x would be the square root of x over the square root of 4 minus x squared. We can simplify this. When we have a square root on the top and on the bottom, it would be the square root of x over 4 minus x squared. This would be our function. This is f divided by g of x. Next thing we want to do is find the domain. So there's 3 things that we have to check for our domain when we're talking about combination functions. So we want to check for the domain of f. We want to check for the domain of g, and we want to check the domain of f over g of x. So like the whole thing, what we just found. And then our domain of the whole function is going to be what overlaps between these 3 domains. So our domain for our first function, for f of x, we have a square root. So what can we not have under the square root? Negatives. So we'd say whatever's under our square root has to be greater than or equal to 0. So our domain here is x is greater than or equal to 0. So just to kind of visualize, let's put that on a number line. So if x is greater than or equal to 0, so we're talking about values that are greater than 0, so it would be to the right side. So I'll call this 0. It would be to the right side there. Now let's find our domain for g of x. So we're going to do the same thing. We're going to set whatever's under our square root greater than or equal to 0. So 4 minus x squared is greater than or equal to 0. Now we have to be careful here. When we're solving, we can... a couple different ways that we could do this. We could move the x squared to the other side, so 4 is greater than or equal to x squared. So just added it to move it to the other side. And then square root both sides. So x, let's keep it here. So x would be less than or equal to what? What's the square root of 4? Just 2? Plus or minus 2. Now we have to be careful with this because we're talking about in between 2 values, either in between or outside. So we've got -2 and 2. We always want to test a number to see if we're talking about the domain that's in between these 2 values or outside of the 2 values. So what's a number in between that we can test to see if it works? 0. Let's plug in 0. So when I plug in 0, I get 4 minus 0. Is that greater than or equal to 0? Is 4 greater than or equal to 0? Yeah, so it would be in between. You can test another number. You can test something outside like 3 and see if that works. 3 squared would be 9, so 4 minus 9, is that greater than or equal to 0? -5. Is that greater than or equal to 0? No. So 3 does not work. So only in between -2 and 2. And they're closed circles because it is less than or equal to. So -2 and 2. So we're talking about in between these two. Now we also have to be careful because we have to check our domain for f divided by g of x. If we have a fraction, what can we not have in the denominator of our fraction? What can that not be equal to? 0. So here, this can't be 0. So all the math that we just did when we said it was greater than or equal to 0, it actually cannot be equal to. So it's the same thing. 4 minus x squared has to be greater than 0. It can't be equal to. So that actually just means that we would have open circles at -2 and 2. So it's the same domain. It just can't be 0. We can't have 0 in the denominator. Now for our domain of the whole function, it has to be what overlaps. So what overlaps between the 3 lines that we have here, the orange, the pink, and the purple? From where to where?
0 to 2.
Awesome. Would 0 get an open or closed circle, or a bracket or parentheses? A bracket 0 because it's a closed circle, so bracket 0. And we said to 2, would 2 get an open or a bracket or parentheses? A parentheses because it's an open circle. So 2 cannot be in our domain. So it's from 0 to 2. So this is our domain. So you always have to check 3 things when you have combination functions. Your domain of f, your domain of g, and your domain of f divided by g. Next, we're going to look at example 7. Now for example 7, it's a little bit different when you have a composition function. So for composition functions, you want to check 2 things. You have to check the inside for the domain, and you want to check the whole thing. So I'll say the whole new function. And it's what overlaps between those 2. So it's a little bit different when you have a combination function versus a composition. For the domain of a composition function, when you have that f of g, or g of x, you want to check 2 things, the inside and the whole new function. So let's find, we can find f of g first. So let's find our function f of g, and then we'll talk about the domain. So f of g of x. Which one's on the inside, f or g? G. G is on the inside. The second one would be the inside. So I'm going to take g and put it inside of f. So we have the square root of 9 minus x squared minus 9. So I took my function g and plugged it into f. Now here we can simplify. What would we have that cancels out right off the bat? The squared and the square root. So those cancel. We have 9 minus x squared minus 9. What cancels here? The 9s. 9 minus 9 would be 0. So negative x squared. So f of g of x is negative x squared. Another way that you might see this written is f of g of x, where g is written on the inside. These are the same thing. So these are asking for the same. Now let's find our domain. So for our domain, we got to check 2 things. Domain of the inside and domain of the whole thing. So which was our inside function? G. So we got to check the inside. Now our domain of g, we have the square root. So what can we not have under a square root? Can't have a negative. So we'd set whatever's under our square root greater than or equal to 0. So 9 minus x squared is greater than or equal to 0. We're going to solve the same way here. I'm going to add x squared to both sides. 9 is greater than or equal to x squared. Take the square root. So x would be less than or equal to what? Plus or minus 3. When you take the square root of both sides, you got to put that plus or minus. So we have two numbers here. We got to talk about if we're inside these two values or outside. So I'm going to put them on a number line just so we can see. What's a number we can test that's in between -3 and 3? Sure, let's test 0. So if I plug this into my function here, I have 9 minus 0 squared. Can I take the square root of 9, or is 9 greater than or equal to 0? Is this true? Yes. So it works in between. Now it's greater than or equal to, so these would be closed circles. Second thing we have to check is the domain of our new function. So if I have a negative x squared, so I'll say new function, f of g. What's the domain of negative x squared? Is there anything I can't plug into x here? For negative x squared. If you have an x squared function, your domain is going to be all real numbers. All real numbers. So on a number line, it would be the whole thing. So for our domain of our function here, the whole thing, it's what overlaps between the two. So what overlaps between that pink and blue line? -3 to 3, from -3 to 3. That's where the two lines overlap. Would it get brackets or parentheses? Bracket, -3 to 3 with a bracket. So that would be our domain. So you always have to check two things when you have composition functions. You have to check the domain of the inside and the domain of the new function. The two things that we really have to look out for is if you have fractions. So if I had anything over any term with variables, your denominator cannot be 0. So to find the domain, you'd set the denominator not equal to 0. Or if you have square roots, you'd set whatever's on the inside of your square root greater than or equal to 0. Now, if your square root is in the denominator, so I'll add that one to the list too. If we have a square root in the denominator, since our denominator can't be 0, we'd set whatever's under our square root greater than 0. So these are kind of the three cases you'll have when you have to check the domain. Your denominator can't be 0, can't have a negative under the square root. Like whatever's under the square root, oops, I'll erase it. So whatever's under the square root, you set it greater than or equal to 0, or if it's in the denominator of a fraction, you'd set it greater than 0 because it can't be equal.